Welcome to Cranfield University here in the UK. It's great to have you with us. My name is Toby Thompson. I'm the director of the glorious Grenville Turner Studios here at Cranfield University, a rather grey Cranfield University, rather warm too. If you see behind me, you'll see some grey skies. Great to have you with us. We're here talking about digital technologies and Industry 4.0. If that is of interest to you, and we think it is, then stick around. We're going to be here together live for 1 hour, and if you're watching the recording of this 1 hour session, please get in touch. We want to carry on the conversation. But we're here together for the live session for 1 hour, and in that hour we have, amazingly, 3 Cranfield professors talking about digital technologies and Industry 4.0, the experts in the field. We want this session to be interactive. We want your questions, your challenges, your comments, your observations pretty much at any time as we go forward into this session. So you know where the Zoom text chat is. Maybe tell us first of all in the Zoom text chat, where are you in the world? And what is the collective noun for professors? Put that into the text chat and we'll get the conversation going. So we want to hear from you. Before we meet these amazing 3 professors, let's have a few words from CAIA and from Amon. Amon, over to you.
Good morning, everyone. It's a privilege to welcome you to today's webinar on digital transformation and Industry 4.0, with a special focus on its implications for process safety professionals. So as we stand at the intersection of industrial innovation and digital evolution, the role of process safety is more critical and more empowered than ever before. So today's session is designed to explore how we can harness the new technologies to enhance safety, ensure new technologies to enhance safety, ensure compliance, and build more resilient operations without compromising the human insight and judgment that remain at the heart of process safety. So today we are honored to have with us experts, as has been said, who will share practical insights and forward-thinking strategies. So I'd like to thank everyone for joining today, and therefore let's begin. Thank you.
Amon, thank you very much indeed. And you're going to hear from Amon again at the very end. This is a CAIA production. So thank you, Amon, for joining us. We are joined by greatness on the sofa. Sorry, I've just called you greatness there. A longtime friend and colleague, Professor Colin Pilbeam. Tell us, before we go any further and before you jump into your slide, tell us about yourself, how you ended up doing what you're doing.
That's a long story.
We want to hear a bit of it.
But I'm a professor of organizational safety. I've been involved with safety for the last decade or more, and fell into it completely by accident when I won my first research grant from the Institution of Occupational Safety and Health in the UK. And it's been an upward journey ever since.
You never look back.
Exactly.
Wow. And now you're Professor of?
Organizational safety.
Organizational safety. Any questions on organizational safety? We are in the presence of an expert. Tell us, what have we got roughly today, just to give us a high level?
So roughly I'm going to set the scene as to why we need to think about digital technologies and Industry 4.0. And then I'm going to hand over to 2 colleagues from Cranfield University. When you are asked to deliver a set of training, you wonder who you're going to include in that event. And so it was a pleasure to look in my own backyard, as it were, and discover 2 real experts in the field, in this field.
That's quite something.
Professor Yifan Zhao and Professor John Erkoyuncu. They will be talking a bit later on about their expertise at the forefront of research in this field.
Before we go to your slides, can we just a quick wave to Yifan and John, just to prove that you're not AI generated. Yifan, just give us a wave, just to prove. There you go. I can see a wave. Those are real waves. So we've got these guys coming up. Just briefly, just 10 seconds, Yifan. Just mention your name and your title, your chair.
Hello, everyone. My name is Yifan Zhao. I'm Professor of Data Science at Cranfield University.
Yifan, thank you. And John?
Hi, everyone. I'm a professor in digital engineering, and I'm also head of a center called Digital and Design Engineering.
Brilliant. Stick around, guys, because there's a ton of stuff coming your way, and you've got a presentation too. But Colin, let's cut to you first. You've got us a few slides.
I have got a few slides.
Ooh.
Only 3. Won't take long. but here we go. So I just would like to set the scene. There's a lot of changes in the world, and the change that we see around us gives us the opportunity to think about how we might exploit the power and potential of digital technologies and Industry 4.0 and all that goes with that. And so I just want to set the scene as to why that's come about, how that's come about, and what the opportunities and challenges might be. So what's happening in the global marketplace? Well, there's a change in the labour market. At least in the West, we have an ageing workforce. People with expertise are leaving their organisations, and so how do we capture that knowledge and retain those skills that allow us to continue to develop and progress? How can we do that? Can the technologies help us with the skill capture and so on? As you're very much aware, no doubt, that geopolitics is a rather unstable at the moment. Lots going on in the world. That obviously affects markets and the prices, and so where globalization was the dominant force, perhaps we're now going back to much more national and insular views of how things happen. What does that do to our world? How do we communicate and operate in that space? Another key and growing issue is the whole area of sustainability and the expectation that industry will be greener and leaner, producing less CO2, making more use of sustainable use of materials, recycling. All of those things become much more common than they were 20 years ago. So how are we going to cope with that? Can the technologies help us? And then, as I say, the pace at which technologies are developing and the competitive advantage that others have who exploit those technologies, what does that do to our marketplace? What does that do to our product lines? How do we ensure that we can compete and expand and exploit these opportunities that are available to us? So a number of significant changes in the global landscape that will affect how we use this material. And these create a number of challenges. So clearly that require us to be agile and flexible. Customers want different product lines and they want to switch from one to another at short notice. This increases the complexity, the opportunity to produce different sorts of products. That adds complexity to our processes. We're not continually producing the same thing week on week, month on month, year on year, where it's much more modular than that. And some of that also then plays into this next issue, which is around the ability to transfer data. Often we hear that organisations are quite siloed. Even within organisations, the ability to transfer data from one process line to another process line is quite siloed and quite challenging. How do we do that? Do the technologies allow us to integrate this data and have that interoperability across modules and throughout the product life cycle? So how can we do that? These are some of the challenges that we're facing. Obviously, there's, as I said, greater interests in how we manage energy and resources. We're aware that these things are finite. We're aware of the impact that they have on the wider environment around us. So how can we optimize our resource use to be more efficient and to comply with the regulatory environment, which is becoming stricter? And that perhaps occurs through the legislation that's increasingly coming in that's curtailing what we can do in different situations, different circumstances. So how does technology help us respond to this new environment? What do we have to do differently that we hadn't done before? So those are some of the challenges that we're faced with, and maybe these digital technologies, Industry 4.0, does this give us some escape routes, if you like, some ways out from these problems that we're faced with? And I lastly want to draw your attention to this very recent report by the International Labour Organization, published a matter of weeks ago, I think at the end of May, that talked about how we can use AI and digitalization at work to control and improve health and safety. clearly my area of expertise, organisational safety. I'm very interested in this. But this report talks about the various ways in which the technologies can be used, from robotics, from monitoring systems, from virtual reality and so on. And what does that allow us to do in terms of understanding and predicting in real time things that might be happening? How does that help us to streamline our tasks? How does that give us the opportunity to create simulated environments which allow us to practice our emergency responses and respond appropriately? It also suggests that there might be some downsides to this technology, and maybe we want to talk about that later on. But I just want to leave you with those thoughts, and there's the web link there for you to click on and download the report to see what the ILO has to say about this topic.
Colin, thanks for setting the scene. And Rolf, thank you. South Africa. I think everyone's South Africa here, by I imagine, but you've called collective noun for professors a faculty. Very precise way of putting it there. Just to let you know, we want your questions, your challenges, your comments, your observations pretty much at any time in the Zoom text chat. So please type away. We're welcomed by our first guest now, Yifan. So Yifan, if you can tell us a little bit about AI and the application of AI. I know you've got some slides for us. Yifan, are you there? We're not hearing you.
Yeah, I haven't. Can I see the slide,
Yeah,
please?
okay. Let's put the slide there. Go.
Okay, yeah, I got here. Yes, Colin just mentioned about the AI rules for the health and safety. So here I'm going to talk about some AI fundamental and application industries. Next slide, please. So everyone is talking about AI at the moment here. So what exactly AI can do? Essentially, originally, AI is about to develop some human intelligence, and which we learn from how human behaviors here, but using some computational methods here. I would like to use one example as one of the most popular function of AI, like object detection. Okay, this is a cup. How AI works. Next slide, please. Click, please. So this is how human brain here. So neuroscientists try to understand how people behave here. They usually have 4 levels, from the retina levels, then people can sense the edge, then can sense in the shape, then they can reason in the object. That is how humans try to understand what is the object here. So another rule of the AI is from the computer scientists here. Next one, please. So they will develop some computational representation to mimic this process. That is what we call some neural network. When they combine together, they will become very powerful. So that is how AI works. For example, facial recognition. So we get the image, then we detect the edge, we detect the shape, then we reason in the face. So we can do the facial recognitions. So that is the origin of AI. But now AI become even broader here. Some of the AI functions are not necessarily original from humans. So I would like to define the AI function in 3 scopes here. So the first one, as the most popular one here, is AI that augmented or replicated human capability. So do what human can do, but in a much faster and more accurate and at scale way here. For example, if you show the picture here, can you count the number of faces? Okay, if you are not hurried, yeah, you can do it. Take times, right? But AI can do in milliseconds. So that is one function of AI. Most of AI functions in these areas. The second one is more powerful. AI that enables superhuman capability. Now these days, AI can do some human cannot do or cannot do reliably. For example, AlphaFold, you probably heard of. This was developed by Google DeepMind. This powerful tool can predict the protein structures, which is usually impossible for human manually. But now AI can do it very accurately and reliably. Third one, this is a new trend. AI that extended cognitive boundary. That is more about how AI and human can work together. They can create some new idea, new design, and solutions. A very popular trend here, a picture, coding. Now these days, software engineering, they don't have to develop code from scratch. AI can generate a majority of code, and then the expert can amend the code here to achieve the target. So that is 3 main functions. Next slide, please. So you have heard of lots of terminology in these areas like AI, So I mentioned about AI concept. Also talk about the machine learning, neural network, deep learning, generative AI. This is some topological relationship between them. So machine learning actually is partial of the artificial intelligence. That is a way, and click please. So that is an approach to act without being explicitly programmed. I'm going to talk about it in the next slide. One thing I would like to pick up here is deep learning is something is quite extraordinary, because that is the main drive of AI becoming flourished in the last 5-10 years. So they bring some advantage, some other data science approach cannot do it. Now these days here, people also focus on generative AI, which is part of deep learning. A typical example like ChatGPT, that is part of the large language model, which also belong to the generative AI. So that is the relationship between them. But these days here, most people talk about powerful AI. They are talking about deep learning, actually. Next slide, please. So how learning-based method works in comparison with some non-learning methods here. So, okay, 5, 10, 20 years ago, when I was at university, we do programming, right? We can write down the rules using some codings, which can establish the relationship between the input and output directly. Machine learning is working slightly different here. In some scenarios here, writing down the rule is very difficult. We don't know how to correlate them. That is how machine learning can play the rules. For example, once you have some data with some high quality labeled data, which means we know the output, then we can use AI to train the model, which means they can explore the relationship automatically. Then we will get a trained model. With a trained model, we can do lots of things. So the process is slightly different. So you probably heard of some AI have problem is rubbish in, rubbish out. That is true, because it is very much rely on the quality of the data, input data, and labels. Next slide, please. Right. Now we talk about slightly more deeper about the machine learning and the deep learning. I mentioned how deep learning becoming very powerful. Why? So traditional learning-based methods, we still need a lot of human-based effort. For example, this example, we want to detect if the picture have human or not. So traditional methods say, okay, we have some positive image, we have some negative image. Then we will develop some we call handcraft feature, which means can we extract some feature which can represent human, for example, edge detection. Once we have the edge, then we can apply some traditional machine learning methods for classifications. So the performance of this kind of approach is very much depends on the handcraft features. Next, please. Deep learning works in a different way. They will develop some deep neural network, click please, which we call convolution neural net, which can replace the second and third step. So the input will be the data directly, output the class. So we don't have to develop our own handcraft feature anymore. So it's much easier to do it. We don't have to develop a very deep understanding of the problems. But for some scenarios, we really don't care. For example, facial recognition. We are not really so care how we learn it here. The result matter. But in some scenarios here, this kind of black box may be not so appropriate. We need a little bit transparent. So I'm going to mention it later. So that is why deep learning becoming so popular now. Next slide, please. So I will give you one example here. That is some project we have done with InDutch previously. We try to identify, can you play the video, please? We try to identify what the person is doing in the car, like, so okay, they are emailing or gaming or browse website, whatever. This kind of subtle movement. So traditional methods here, we will measure the hand movement, right? The middle image, it shows the hand movement here, right? So then we can use some AI methods to analyze hand movement, make a decision what they are doing here. Next slide, please. Deep learning will be doing complete different ways. Can you play all the video, please, together? So now same experiment here, but we only input the video directly, and the output will be the type of the activity. So we really don't need to understand or extract what is useful information for these classifications. So some methods can help us understand where AI can learn, but this kind of approach for most of methods still acting this kind of black or gray box manners. So that is why in some scenarios, deep learning becoming very attractive. Next slide, please. So what machine learning or AI can do? So here I try to categorize in 3 groups. There are some other groups as well here, but this is 3 most popular one based on the data we have been given. The most popular one we call supervised learning, when you have the data and we have the labeled data, right? Some functions, most popular function, of course, is classifications related to the safeties. So for example, do some diagnosis or some prognosis. Usually there are some classification problem. We also can do some predictions. Prediction is more related to regression problems. So output is not a certain class. It is some certain values. For example, it can calculate some remaining use life of some certain component. Reinforcement learning is the most close way to how human learns. We have some initial models here, and also we learn during the operation with the environment, right? One typical example, gaming AI, you probably heard of AlphaGo, right? Because it can beat human easily now because it learned during the games. Unsupervised learning is another typical approach here is when the data are not labeled here, they still have lots of applications. Next slide, please. Now I'm going to talk about a few functions we developed for construction areas. I have been working in these areas in the last 5-10 years. And one of the example is supply chain monitoring. Construction want to monitoring the vehicle in and out. And then they want to record it here. Usually it is human related here. The vehicle need to stop and then takes a note here. So we develop some AI systems which can monitor which vehicle is in and what type of vehicle is in. So that is something ANPR system cannot do. So at the end of the day, we will produce this kind of logbook automatically, which vehicles, what is the registration plate, how long they stay on the site here. Also, we have some raw image which can verify our result. So this kind of function is important because sometimes because of private reasons here, we cannot monitor the civilian private vehicles, but ANPR will monitor every vehicles. So that is a dedicated functions for construction monitoring. Next slide, please. AI has been very well used for measure productivity in different sectors. In construction as well, for example, AI can track a machine, what type of machine, what they are doing there. It also can track in the behavior of human as well. With such information, we can develop lots of insight for industry. For example, next slide, please. We use this function, we can develop some insight about how the dumper and excavator can work together to make sure they can deliver the highest productivity. For example, when one excavator and one dumper work together, they usually can complete 8 cycles in 1 hour in our scenarios here. Then we can find out that there are 55% of excavator in idling. That is not looking good because excavator is very expensive. So if one excavator can work with 2 dumper together, the number of cycles can be increased 24 cycles in 1 hour. So idling time has been reduced 25%. So from this kind of approach, we can understand how these 2 machines work together, and then this information can feed back to operations operators for fleet management. So it is related to Colin's previous slide, talk about the resource optimizations. Next slide, please. Another function is more related to safety. We call contract risk identifications. So now the large language model itself can have a greater capability to reason in some text. So they can go through some very lengthy construction contract. They can produce structure risk register automatically. And then based on this kind of register, we can develop some site monitoring technology to look at the safety, economic impact, environmental risk, legal risk, and a societal risk. Then we use some multiple model AI to analyze the data from different type of sensors to make some prediction. Is there some safety issues? Is there some risk of cost overrun, for example? So this kind of the combination of the generative AI and the traditional AI becoming more and more powerful. Next slide, please. A little bit about key challenge for AI adoptions. Look at futures. Now, this day here, lots of AI function has been developed, but they are not necessarily has been adopted by industry. Industry have a great concern in terms of two sides here. One is the trustness of AI. Second one is responsibility of AI. So I'm not going to go through all of them, but they are more like care about if the AI model is reliable for different environment. If you work in this scenario, would this AI model works for another scenario here? Have you validated comprehensively security? Is it vulnerable to malicious attack? Responsible AI, for example, transparency. Everyone is talking about the black box nature of the AI. Can we open the box? Can we let AI to explain to us how they make decision? Because if we can understand the decision making, we will become trust the AI, then we will welcome the AI. So lots of countries now, they are developing different, they have their own regulations. For example, European just promoted the EU AI Act, right? So the purpose of this kind of the regulation is try to everyone can benefit AI in a quite safe ways. Next slide, please. I would like to finish the slide with two birds here. So we have two very intelligent birds, parrot and the crow. Parrot is very good at mimic what people talking. When they observe people talking a number of times here, they can do exactly the same. From a computer science point of view, so that is what we call learn from large data, and then it will complete a simple task or a very specific task. That is where we are currently our AI here. We need some high quality data to achieve a simple task. Crow is one of the most intelligent animals in the world. They can do something astonishing things. For example, they can help let the vehicle to crash nuts for them, and also then pick up the nuts safely and avoiding traffic. The way it works is quite different here. They don't need to observe this kind of behavior lots of times, but they still can complete such a complex task. How do they do it? So that from computer science point of view, we need a little bit of data, very limited data, but can it complete a complex task? From my point of view, that is our futures. Yeah, thank you very much.
I love that finish. I wasn't expecting crows and parrots there. It's fantastic. Yifan, that's fantastic. You put it in a very simple way for even me to understand. So thank you. Stick around because there's another presentation from John coming up. This is a question for you now. How are you thinking about this? What is it doing to your context, your area? Connor, can I ask you, is your glass half full or half empty when it comes to the application of AI? You're not catastrophizing about AI?
Half full, I think.
Half full.
There's terrific potential, but I think there are some caveats that we need to be aware of, which Yifan has just expressed and shown us. You know, there are things that we need to trust. We need to be confident about the reliability, but that's open for discussion on the chat. What are your views? You know,
perfect segue. We want your questions, your comments, your challenges. Please put them into the Zoom text chat. And if you've gotten this far into the recording that you're watching, then we want to stay in touch with you. Get in touch so we can carry on this conversation. It gives me fantastic pleasure to welcome John. John, it's fantastic having you back in the studio there. Just before we go further, are you a parrot person, or John, or are you a crow person?
Well, we need a bit of both, probably.
I knew you'd say that.
a carrot.
A carrot. Yeah, I love it. John, over to you in your presentation.
Okay, thank you very much. So in this presentation, I will introduce the topic of digital twins, and I will give you some examples as to how digital twins are being used and how you might consider taking these forward in a construction context. So next slide, please. So next slide, please. So just to introduce the concept, so I guess it's building on from what Yifan presented here. We're trying to have two-way communication between a physical asset and its digital representation. So what you can see on the right-hand side is that we have the mechanisms to collect data from the physical object. It could be a building, it could be an engine, it could be whatever you define as a critical system. We collect that information, feed it into a simulation, an optimization, a mechanism where you're going to define what improvement is needed. And that then communicates the recommendations back into the physical object. So by communicating into the physical object, we're able to make some changes in the behaviors of that asset. We're able to maybe improve the life cycle. We might be able to improve productivity. Depends on what criteria you have, but ultimately this two-way communication enables improvement over time. Now, if I compare that to a digital model, there's no direct relationship between the physical system and the virtual model. So we're not necessarily collecting data from the physical system, and it's potentially out of date. The model becomes out of date over time. The digital shadow in the middle is really showing that there is a link from the physical object to the virtual object, meaning maybe we have some sensors, we're able to collect some data from the physical system, and the optimization is updated. So it is representing the physical system, but there's no direct link back into the physical system. So you can see in terms of the computational power, in terms of our ability to build these, there's an evolution. So from models, which was more traditional, these are things that we've been doing for many decades, to digital twins, which probably has been around properly for the past maybe 7-8 years. Next slide, please. So if you could please play the video. So this example is showing a compressor context. So the question for us was, this is a factory where there are numerous compressors. And the question that we were given was, how do we improve our understanding of the health of these compressors? And how do we actually also improve the way we manage these compressors? How do we have better productivity and reduce the impact of failures? So in this example, what we did was we built sensors, we integrated the sensors, we operationalized these sensors, and we built some models to determine the health of these compressors. So we looked at visualizing this. So green illustrates that the health of the compressors is good. Red illustrates there's a problem. And we also created a sort of digital portal for people to engage with the systems. So the digital twin element is coming from that angle in terms of giving instructions back to the machine, improving the way we're operating the machines so that we can maybe extend the life or improve on the failure characteristics. So ultimately, this had two-way communication, and we could improve the way the facility, the overall factory was operating. Next slide, please. Again, if you could please play the video. So this example is looking at gearbox context. So the question for us was, how do we realize the health of the gearbox? And how do we actually also improve the feedback back into the gearbox? So we're visualizing this current health condition using augmented reality. And we've also built a communication between the digital representation, where it's looking at the temperature, vibration, those kind of sensors feeding information. We're optimizing the remaining useful life, and the feedback is in terms of the speed at which the gears are running. So we have set some limits on the gears based on the temperature conditions and the vibration conditions. So these are simplistic rules, but ultimately those rules help us to manage the life cycle of this asset. So again, we're looking at that two-way communication and trying to enhance the life cycle. Next slide, please. So this example is in the context of how do we have resilience in systems. So you can see there's a round ball at the top of this system. And the question we have is, if one of these legs that are balancing this system, if one of them stops working, and you can see here we're removing the cable, so one of the legs stops working, how does this overall system manage to rebalance itself? How does it start to ensure that that ball doesn't fall down because one of the legs stops working? And that's exactly what the digital twin resilience system that we built is looking at, in the sense that not everything will go to plan. And how do we now have a resilient system to cope with changes in systems? So again, there's a huge opportunity, I think, with using digital twins to enable resilience. Next slide, please. So this next example is looking at the context of wind turbines. And the question we have here is the yaw misalignment. So this is the angle at which the wind turbine adjusts itself based on the wind. And it adjusts itself based on the direction of the wind, based on the sensor feedback that we get. So if the sensor stops working, we then have a challenge in the sense of how do we realize the optimum direction to have the wind generated, the energy generated. So the context we developed was we created an AI-based approach where we could fill data gaps synthetically when the sensor stops working. So that way we can start to predict where the wind is coming from and what speed at which the wind is coming at. And we can start to improve the energy production process. So again, a digital twin approach in that we first need to realize if the sensor stops working, and then we need to generate the data to fill the data gap. And then we also need to make some predictions in terms of what is the direction and how do we actually manage that direction. So next slide. So this is just to highlight that we have a couple of relevant courses that might be of interest to yourselves. Firstly, we have a course on digital twins for senior leaders. This is very much looking at applications and trying to build a long-term maybe strategy for how you could use digital twins. We also have a master's course looking at digital and technology solutions. So this is really about how do you develop practical solutions and how do you start to embed these practical solutions in your organizations. So very hands-on and very much about impact in your organization. So that's a part-time 2-year course. Good. Next slide. Thank you. So in this next slide, I just want to give you some reflections and some maybe insights as to where digital twins can be used moving forward. So firstly, I think one of the key advantages of having digital twins is around resilience. It's in terms of how do we respond? How do we react to changes in complex systems? So how do we maybe prevent a potential failure? How do we deal with a failure as and when it happens? They're quite critical in complex critical systems. There's a huge area of interest around predictive analytics, and I think the types of approaches Yifan presented around AI can fit in very nicely to improve the accuracy, to improve the way we optimize complex systems. And there's another key dimension to consider around how do we manage data? How do we start to look at complex systems where there's lots of different sources of data, lots of different types of data, and how do we integrate all of these so that we've got a complex system represented holistically, and we can start to see how we can improve these systems over time. So again, there's huge opportunities, very exciting times, and we're looking forward to seeing how digital twins are implemented across sectors, which is currently happening, and lots of good benefits are being realized. So I'll stop there. I'm looking forward to the discussion.
John, thank you very much indeed. I love those videos there. I didn't understand how you unplugged one and it still carried on working. So impressive,
Yes,
very impressive.
absolutely.
Incredible. Again, a reminder, you've got a couple of questions, so thank you for those 2 questions that are in the chat. Your chance, if you've been disturbed or encouraged by anything that you've seen here, or you want to ask that key question to John or Yifan or Colin, then please, now is your chance to do that. We do have a couple of questions. First one's from Barend, and Barend, I'm with you on this one. Barend thinks there's a load of nonsense on the internet, but on which data are LLMs, ChatGPT, Gemini, etc., trained, considering how much nonsense there is? Can I put that to you first? I might go to Yifan. What do you think?
I think that's probably true. Depending on what it's the garbage in, garbage out that Yifan was talking
mentioned
about.
it earlier on, yeah.
So I'm going to hand over to Yifan to give us a considered view rather than an amateur's view, which will be mine.
Baron's asking, on which data are LLMs trained, considering how much nonsense there is out there?
I guess that is secret, right? And they were never published what exactly data they published, they utilize. I feel in the future here is data itself is a asset. It is the capabilities. AI model itself is the tools everyone can share. So in terms of large language model itself, what kind of data they use, I'm sure they are very diverse and there's some different sources. That is why only some large company can, it's not only about their computing capability, but also their capability and resource to access different type of data. They have huge amount of resources to validate the data, to issue the quality of data, because as mentioned, rubber in, rubber out here, and that is very likely. So another thing is when they started operating the large language model here, they also had dedicated team to gathering information, gathering some high quality information, which can further improve the quality of large language models. They will not utilize all information we type in the ChatGPT for training, for sure, because that can really damage the systems. So I'm not quite sure if I understand your questions.
I guess Baron doesn't want the training to be done on the nonsense that's existing out on the internet right now. Baron, feel free to come back and we can carry on the conversation.
It raises a really interesting point, doesn't it, Yifan's response around the ownership of data and the quality of the data, and the data is your asset and not the tool that's using to manage it. So how confident are you in the data that you've got, and how good is it, and what can you use it for? I think that's probably an interesting angle to exploit and explore a bit more, perhaps.
John, have you got any take on that? There is a question, John, for you coming up, but what do you think on this one?
I think for me, I mean, we've used large language models in the context of maintenance planning, and the question we had was, how can we improve the time it takes to do diagnosis? So the approach we took was to look at historical reports on different assets where a report was written in terms of what was done, what the maintainer saw, and what sort of observations they had and what actions they took. So in that process, we could analyze around about 6,000 reports and text-based analysis, and it had a huge impact in terms of reducing the time from roughly 3 weeks to do a manual analysis of the cause-effect relationship for the failures to roughly a few hours. So if you pick the right use cases, there's huge potential, but absolutely there's huge challenges around the data.
Brilliant. John, there's another question for you, and this is from Christoph. And Christoph, thank you for your question. Is the algorithm to determine an asset health determined by expert input, or is that done by AI approximation?
So in that example that I showed, it was expert input. But moving forwards, we could have AI developing the rules. We can have also AI having a much more kind of active role in determining the health. So, yes, I think at the moment we're sort of building on, but we heavily relied on expert opinion in that.
Thanks, John. And Christoph, feel free to come back on that one. It sounds like you're worried about the AI input there, but let us know. Question from Oratang, and this, I think, Colin, this one is to you. Oratang is asking, how easy or difficult is it to incorporate AI into the safe operations of plants, for example? That's a massive question. Where do you start?
Yeah.
What's the criteria by which you start?
Yeah. Obviously, yes is the simple answer. How you go about doing that, I suspect, is more complicated, and it may be a case-by-case basis. But the potential for integrating the different systems, the different parts of your systems, to monitor what's going on in one part, and then have that feedback into the subsequent parts, as John was indicating in his presentation. I think that has tremendous potential. But clearly, there's a capital cost that goes along with this, and so how that works in practice, I know there are organisations that are doing that. Some of the big the companies that do the alarm systems, they are developing those sorts of capabilities so that the alarm actually then indicates what it is that you need to do, cutting out the risk of responding incorrectly to the wrong alarm. That reducing those risk opportunities that occur with humans being involved in the loop, as it were. So yes, I know it's happening. It's expensive, but there are opportunities there to use. So yes, it's potential, and certainly going forward, it's a real possibility.
You mentioned cost there, but I guess one of the costs is human lives. The lives are at stake getting this wrong.
Absolutely getting it wrong, but the argument, I think, would be you need people in the system to monitor, but if you can get AI to do the basic monitoring for you, then that may be something that where you'd want to move the human out, but keep them in control of the more sophisticated parts of the system where you needed to react more quickly, or at least more in a way that we understand. Perhaps more going back to Yifan's point about the black box, the concern over whether the AI is the black box that we know nothing about and how it operates. Maybe we need to keep people in the loop for a bit longer,
Yifan,
to ensure that works well.
Yifan, what do you think? Keep people in the loop or trust in the black box?
Well, I think that has been debated in lots of sectors. My personal view for the health and safety areas here, human in the loop is crucial. And we have seen lots of examples in industry here. They are a bit cautious to apply AI for safety-related applications. For example, here is AI make a mistake, right? Maybe occasionally. But when we make a mistake here, who takes the responsibility? If this kind of rule has not been well defined here, industry is not comfortable to apply AI. So my opinions at least in the next few years here, AI will be deployed in health and safety areas here, but they will develop some additional rule for human to oversight AI, make sure it can work reliably and also responsibly.
John, can I ask you a similar question related to Oratang's question? Looking forward, how far can these technologies take us? For instance, are we expecting zero accidents with the use of AI? Is that ridiculous?
I mean, it's a good aspiration, but the challenge also is with AI, we have to educate AI. We have to build some data. If we experience new events that we haven't necessarily experienced over a long duration of time or ever, it could have an impact on the ability of AI to predict those. So, can we guarantee that there will be no issues or safety issues moving forward? I don't think we'll be in that position. So, but the possibility to improve on safety, I think, is real. It's possible, and AI can play a huge role in improving safety considerations.
Going back to your point about humans needing to be in the loop, aren't there still more stresses, different stresses, that we haven't fully explored when we rely more on AI?
Yeah, that's a serious concern. So I referred to the ILO report, and I drew out all the positives in my slide, but back in the back of the report there are some negatives there about what might go on. And one of the concerns that people have is the ability of AI to monitor, and these digital tools to monitor people's work. And so there's as Yifan showed in his diagram of the dumper truck and the excavators, you can make people work more quickly because you've got more stuff there and there's less downtime. So the sense in which people can control the workload and try to optimize that, what does that do to the human natural instincts to have highs and lows during the day and allow that sort of dynamic change in the diurnal rhythm of work, the pace of work that we all go through. If they're wanting continual high performance at a very high level, that creates additional stresses. And so this prospect of being monitored in terms of your performance, I think, is adding mental stress, and people talk about that quite a lot in the occupational safety area. So yes, great tools for managing processes and automating processes and making them, taking people out of risk environments where you can get the digital technologies, the robots and so on to do that for you, but actually adds in the stresses that go with it, the mental stresses. So you're changing the physical harm to a mental harm. There's issues around that we're concerned about at the moment.
Yifan, are we seeing a pause because of this issue of human lives, or is this an area of development? It sounds interesting. There's a balance there.
It is. I think ironically here is people make a mistake, right? People make a mistake here. Okay, there's some regulation. AI make a mistake here. When AI make a mistake like a Tesla, when accident happen here, it is always say, okay, it's the technology has a problem there. So people will lost the system here. So I think that is some areas here is I mentioned here is quite difficult in health safety areas. But I would like to highlight the positive side in AI here. AI is here in this area is not try to, okay, I will make people life, maybe operate life more easier. I can replace, I do some lots of work you can do, make more effective. But AI can do something human cannot do, as I mentioned in the second scope here. In some scenarios here, AI can predict something is going to happen, but a human cannot, because that is something I think we have to realize it here, because it can really enhance the capability and the health safety monitoring. But I think if we can manage the risk very well, how human and the AI can work together, I'm sure this is the future.
The future, wow. John, there's a question for you, and this is around digital twins. This is from Christoph. Christoph, you're on fire today, thank you. I suspect asset health algorithms can be refined by training the model on digital twin simulations and real object results. Have you come across this approach, John, in industry?
Exactly. This is, again, a good opportunity in terms of how do we start to compare our estimates, the way the models are performing, against the actual outcomes. So if we can start to see whether models are not performing well, we can actually provide some feedback and improve the way the models are designed. So I think there is a big opportunity to improve health as an outcome, the asset health, and there is a big opportunity to improve the accuracy of remaining useful life analysis. So I think the thing about the digital twin there is you need to design the digital twin in a way that it's continuously improving and it's learning over time in terms of how it's performing. But yeah, very good point. Thank you.
There's a question from Rolf, and thank you, Rolf. I'm not sure who to put this to, so I'm going to put it out there. Rolf is saying, what are some of the practices that can be deployed to drive adoption of AI and related tools in organizations? The challenge being that often AI-based implementations are discredited before they get a solid footing. Who wants to take that? I'm going to go to Yifan. Yifan, what do you think from Rolf's point? AI implementations are often discredited before they get a solid footing. So why trust them?
Well, I think that is it is something is related to some public perceptions of AI tools here. As I go back to my previous point here is, when AI make a mistake, the perception changed here. It's quite difficult for people to build up this kind of trust. So trust build up slowly, but trust can go down very quickly. So I think that is sometimes here people don't trust at the beginning here. I think to gathering trust here, it must be from the public resources, also during the operation when you use it here. And maybe, as I mentioned here, it is perfect opportunity to work with in the digital twin concept framework John was talking about here. We can implement AI tools in the virtual environment first here to see what is going to happen. And then we don't need to take the consequence. And then once we can verify the whole process here, then we can start it to implement in the real world here. So there are different ways to build up this kind of the trustness, but it takes time.
John, it takes time to drive adoption for digital twins. Would you disagree with that?
I would agree. I mean, I think there's maybe perceptions that it's costly to develop digital twins, but it's also that the mechanisms to collect data from the assets are not in place, which will require some investments. It'll also require some investments to design the data architectures and the interoperability. So those kind of things do require development if you don't have them. And I think you need some standards also in place so that there's common practices, common approaches, so that you're sustaining the development over time in a consistent manner. So yes, there's a number of things needed, but I think the key thing here is commercially, it needs to make sense. So if you've got a good business case and over time you're going to get the benefits that you need, it's worth going down that path.
John, thank you. This is to you, I think, Colin. This is Noel. Noel, very interested to hear what you're doing there. Noel's talking about this. It's still a very unexplored area, the human-machine interface. It's critical but unexplored. In the process safety area, have you come across any particular company that's in doing this?
I think I would push back on that a little bit. I think we know quite a lot about the human-machine interface, particularly in aviation, and the translation of that knowledge into the control rooms and alarm systems and so on that we talked about at the last webinar, and the human factors piece, that the ergonomists and human factors specialists are working very hard in that space. So I think we do know actually quite a lot about how that works. It may not have filtered down into the older chemical plants that might be existing in different parts of the UK even, but probably around the world as well. But certainly there is a lot known that could be translated and transferred.
So Noel, bit of a pushback there, but feel free to come back to us and carry on the conversations if you're watching the recording you've gotten this far. One last question I think we have time for. This is from Hein. How does one translate the innate knowledge and experience of, say, a technical turbine engineer or technician into an AI model? John, where do you begin? You're going to say digital twins, right?
I think we need to capture tacit knowledge. That's a critical thing where people accumulate knowledge over time. Now, how we capture that, there's a lot of work going on, and we've been looking at something called ontologies, where you can formalize different types of data. You can start to define knowledge in a standardized way. And you can also start to build relationships between different people that has different kinds of knowledge. Just as an example, like the term corrosion, different people may define the term differently, or they may use a different word to define corrosion. So when you're trying to map this over time, you need to understand the relationships and how they're linked to each other. So things like taxonomies could be useful to build. And building these will then give us a more structured way to capture knowledge. But it's not a perfect process. So, you know, it's a process you need to go through over time where you're capturing this. It doesn't happen overnight.
John, sadly, we've got to stop you there. It's been fantastic having you both, Yifan and John. Thank you so much for your time. We have run out of time. Stay in touch with Cranfield and those two courses that John talked about. Look those up. Colin, thank you very much. We're going to close with a few more words from Amon to talk a little bit more about the CAIA opportunity. So Amon, over to you.
Thank you very much. I'd like to extend my sincere thanks to each of you for your time, attention, and engagement. And CAIA is encouraging you to take what you have learned today to your teams so that we can use these teams, continue the dialogue, and see how we can apply those tools to our own operations. So CAIA, together with Cranfield University, are going to be hosting more events. We are going to have the Sustainability and Circular Economy webinar, and it is going to be on the 9th of October 2025. We are also going to have the Emergency Preparedness and Response Training course starting on 7 October for 4 days over 4 weeks. We are also going to have a Process Safety Conference from the 9th to the 10th of September 2025. And this is going to be a hybrid event. So we are looking forward to your participation in these events. And thank you once again for attending today's webinar. You have a nice day.